Alright, so we're going to factor quadratics when the leading coefficient is not 1. So in this case it's a 2. So like for example, we could rewrite this quadratic as 2x minus 5 and x plus 6. Now what we're going to notice is when we multiply these two together, we get 2x squared. And then when we're working on our inside terms, this 2x gets multiplied by 6 for 12x, and then this negative 5 and that x give us a negative 5x, and then at the end that negative 5 and the positive 6 will give us the negative 30. So what we see here is that when we look at our factoring, we can see where these numbers are starting to come from. The numbers that are first, the 2 and the 1, those are factors of 2. And then the negative 5 and the positive 6, those are our factors of negative 30. What we can see is that some of these factors of the 2 get intermixed with some of the factors of the negative 30. So our factoring method is going to be a little bit different. So what we know is that we need to use the factors of A. So like the factors of 3 are just 1 and 3. And then the factors of 5 are just going to be 1 and 5. So what we know is that at some point those factors are going to be intermixed, and then they're going to combine to be the middle term. So on this case, we want two products to combine to be negative 14, because that's our b value. Now we also notice that if I multiply to be negative, I'm going to need one negative and one positive. So I want to get a 14 somehow. And I see that if I were to connect the 3 and the 5 and a 1 and a 1, that would give me a product of 1 and 15. And that would equal negative 14 if the 15 was negative. So where can I get a negative number? Well, if I just put a negative with the 5, that means 3 times negative 5 would be negative 15, and 1 times 1 would be 1. So when I'm making my factors here, the factors of A always go first, as we saw in the previous example. So my factors of A are going to be 1 and 3. Now the factors of C are going to be our last numbers in the parentheses. But we need to make sure that we want the correct numbers to multiply with the other correct numbers. I wanted the 3 to multiply by the negative 5. The only place this 3 is going to get distributed is in one of these two positions in the first binomial. So the only position it can go to is in the minus 5. And then the other factor of C should be A plus 1. So this is our factorization. Going to factor this one, we notice that in this case our factors of A have more options. It could be 1 and 9, or it could be 3 and 3. And there's a lot of options for 30. It could be 1 and 30, it could be 2 and 15, it could be 3 and 10, or 5 and 6. So when there's more than one option, you're going to need to do some guessing and checking. Our b value is negative 59. So which factors of A am I going to use? Am I going to use 1 and 9? Maybe. Am I going to use 1 and 30? Maybe. But we can see here that no matter how we were to connect these dots, there's no way that I could get 30 and 9 to be negative 59, or 1 and 270 to be negative 59. So what you're going to need to do is just continue to guess and check until you can find the product that's going to work. Now I'm going to use I'm going to use 1 and 9 for my factors of A, but for my factors of C, I'm actually going to use a 5 and a 6. Because what I see here is that I would be able to get a 54 by connecting the 9 and the 6, and then a 5 by connecting the 1 and the 5. If I wanted this to be negative 59, both of these numbers would need to be negative, so I'm going to make my factors of C negative. So in my factorization here, the factors of A are 1 and 9, and the factors of C that I used were negative 5 and negative 6. And I wanted the negative 5 to be multiplied by the 1, so that would need to go in this parentheses, and then this would be the negative 6. The most important thing ever when you're factoring, especially when the leading coefficient is not 1, is always check for a GCF first. because if there is a GCF first, it makes the problem a lot easier. Like here I notice they're all divisible by 2, so I can factor out the 2 first, and then realize after I do that, the resulting quadratic now has a leading coefficient of 1, so we can use that method. So the numbers that multiply to 15 and add to -8 would be -3 and -5. So our final actual factorization here was we have our GCF of 2, and then we rewrote this as x minus 3 and x minus 5. Lastly, this method is easily done if we keep our leading coefficient positive. So if we ever notice that we have a negative leading coefficient, we factor out a -1 to keep our leading coefficient positive. So I'm going to rewrite this by factoring out a -1. So 5x squared plus 12x minus 4. So now I can just factor this. So the factors of 5 are 1 and 5. Now the factors of 4 could be 1 and 4 or 2 and 2. What I'm looking to get is I'm looking to get a product of 12. So I'm going to actually use the 2 and the 2 because I see that I could get a 10 by doing 5 and 2, and I could get a 2 by doing 1 and 2, and of course 10 and 2 makes 12. So our final factorization, we have our -1. Now the factors of A that we're going to use are 5 and 1, and the factors of C that we're going to use is 2 and 2. So it doesn't actually matter where they go because they're going to be filled with the same number here.